Hello, YouTube. How you doing? We're back. What's today's topic? Let's see. What's today's topic? Math. What is CIS theta? Right. Now, aside from being my alternate YouTube channel, do you know I have a YouTube channel where students make filks and I put them there? Right? It's not my main channel. I have a CIS theta 2007, I think it's called. Yeah. For YouTube? Well, I'm talking about the filk channel, CIS theta 2007. My regular channel is calc page 2009. Right? All right, yeah. Can you? Three, at least three. If it's wacky, crazy decimals forever, yeah, three. All right, so what are we doing today? We're doing CIS theta. What does that mean? That means dealing with complex numbers as if they were vectors. Now, chapter 9, this is chapter 9 we're in, right? See the drop box for chapter 9? Okay, chapter 9 is about vectors. And you know pretty much everything there is to know about vectors, really. If you have a vector, what's the horizontal component? R cosine theta. If you have a vector that's not horizontal vertical, what's the vertical component? R sine theta. You know everything there is to know about vectors already. That's it. Simple, easy. All right, so let's use it. This is what we're going to do. We're going to use what we know about vectors and polar, remember polar notation, to make complex arithmetic easy. Okay? This is what we want to do. Let's say I had a complex number z, which is rad 3 minus I. Now, what makes it complex, by the way? Why do I say that's a complex number? Because I, is that it? So this is complex too? No. What's the difference? There's a real part and an imaginary part put together by adding them or subtracting them, right? So there you go. So that's what a complex number is. Now, what I'm trying to get at is an easy way to multiply them, divide them, exponentiate them. If you wanted to multiply like 2 plus I times 3 minus I or something, this is a big production because you got to do what? Foil it, combine like terms, simplify, big mess, right? That's too much work. I'm going to come up with a brand new way of doing it so you don't have to do all that work, okay? But first you have to figure out how to write this in polar mode. Polar notation, all right? So this is what you're going to do. Instead of the y-axis, you have an imaginary axis. Instead of the x-axis, you have a real axis. Now remember that this complex number is written in a plus bi form. What does it mean? A plus bi form, you remember that stuff? The a is the real part and the b is the coefficient of the I. So a equals what in this case? Rad 3, and b equals what? Negative 1. Okay, I'm going to graph that. I'm going to graph it as if it were rectilinear. Those words again. What does rectilinear mean? Horizontal and vertical lines. So graph paper, right? So I'm going to make the real part as if it were the x-axis, and the imaginary part as if it were the y-axis. All right, and I'm going to draw a polar vector. Are you ready? How big is rad 3 about? It's 1.73 something. All right, so if this is 2, 1.7-ish is over here, right? And then b, you told me, is how much? B is negative 1. So say negative 1 is there. It's not drawn to scale, but there you go. See that point? I'm going to draw a vector from the origin to that point. I need math and physics to go together. Okay. So this is like a polar vector. Remember when we graphed the roses and the limicons and the cardioids and the circles, and right? What you have is a vector that is moving r theta, r theta, r theta, r theta, and you connect the endpoint to the vector and you get a shape, right? I'm doing the same thing here. And while adding is easy, it's the multiplying and dividing that can be a problem. Adding is just to add the a's, add the b's, you're done, right? And that's the easy part. All right, so now take a look at this right triangle right here. Let's blow it up a little bit. This right triangle right here. This length is rad 3. This length is 1. Let's call that r. How long is the vector? I want to know how long the vector is. Pythagoras, right? Right, so in other words, it's 1 squared plus rad 3 squared equals r squared. And rad 3 squared is just 3 plus 1 is 4 is r squared, so r is 2. So we're going to say r is 2, the principal root of 4, not positive, not negative, just an absolute value of length. Okay? So that vector is 2 units long. Now I need to know this angle. That's a big angle. How do you get it? Well, it's easier, right? Let me just pretend. What if alpha, I'm calling it alpha just because I feel like it. What if alpha is 60 degrees? What would this other angle be? 300, right? So if you knew the alpha, the other angle is easy. Well, this is easy. How do you get alpha? Sokatoa, right? So the sine of alpha is the opposite over the hypotenuse, 1/2. The cosine of alpha is the adjacent over the hypotenuse, rad 3 over 2. The tangent of alpha is 1 over rad 3. If you rationalize that, it's rad 3 over 3. Do you know any angle whose sine is 1/2? Say. 30 degrees. Alpha is 30 degrees. So what's this big angle here? 330 degrees. So this is what I'm saying. Rad 3 minus I is equal to 2 cis 330. That's what I'm saying. The 2 is the length. The 330 is the direction, the angle. Any vector has a magnitude and a direction, right? Okay, that's how I'm telling you the magnitude by the length and the direction by the angle, right? So this is Cartesian. This is polar. This is r, and this is theta. I'm converting a plus bi form, Cartesian form, to r cis theta, polar form. Okay? Now, why do I want to do that? Because it's so much easier to work the complex arithmetic, multiplying, dividing, and powers in this format than it is in any other format. So let's play with this. By the way, is that a true statement? Is that a true statement?
I don't know.
How would you know? Well, I had to tell you what cis means.
Yeah,
That would help, right? Okay, cis is a function. It looks like I'm plugging something into cis, like f of something and plugging it in. I'm not doing that. Cis is shorthand for this. This is cis 330. You ready? The cosine of 330 degrees plus I times the sine of 330 degrees. CIS, cosine, I sine. CIS, okay? Now, are these statements, are these two expressions equal? How do you know? Well, you got to know you don't need Ziggy, though. These are reference angles. You got to know the unit circle, right? Be one with the unit circle. If theta is 0 degrees, what's the cosine? What's the x value here? I'm the origin. This is a unit vector. 1, right? If theta is 90 degrees, what's the sine? 1. The y value is the sine. No, 1. If theta is 180 degrees, what's the cosine? -1, the x value. If theta is 270 degrees, what's the sine? -1, the y value, right? So what's the cosine of 330? Let's see, where's 330? If this is 30, this is 330, right? Okay. So I'm in the fourth quadrant. The x's are positive, the y's are negative. That means the cosines are positive, the sines are negative, okay? Now look at the diagram. What is that coordinate right there? Right here. Isn't it? Right, if this was the unit circle, notice I drew a vector of length 2. But say this is the unit circle. The cosine is rad 3 over 2. The sine is -1/2. Why? Because it's the same thing as a 30-degree angle, except the 30-degree angle is in the first quadrant, right? In the first quadrant, 30-degree angle has an x value of rad 3 over 2 and a y value of 1/2. So I'm just flipping it, right? Okay, so let's write that down. The cosine of 330 is, you said? Rad 3 over 2. Okay. Plus I times the sine of 330 was what? -1/2. So let's distribute. What's 2 times rad 3 over 2? No, that would be rad 2 times rad 3. If I'm doing 2 times rad 3 over 2, the 2's cancel and you get rad 3. And if I do 2 times -1/2, the 2's cancel and I get -1. Don't forget the I is still there. So is rad 3 minus I equal to rad 3 minus I? So rad 3 minus I is 2 cis 3 theta. 330, I should say. Now, huh? So it does work. Okay. So I'm just saying we know how to convert from Cartesian to polar form, and we know how to convert from polar form to Cartesian form. All right, that's a warm-up. This is what I really want to do. What if I gave you two complex numbers to multiply? What if Z1 equals 3 cis 20? And Z2 equals 5 cis 100. And I'm in degree mode, okay, degrees. It's really easy to multiply. Are you ready? Now remember, before to multiply, you had to do, 1 plus I times 2 minus I, FOIL, blah, 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 big mess, right? Easy. What's 3 times 5? 15. What's 20 plus 100? Walk away.
That's how you add.
That's it. That's how you multiply. That's it.
I thought you said it was more complicated.
No, I said this is easy. This is easier than what you know. Easier than how you know how to do it. If I knew what these were in Cartesian form, I don't know, 1 plus I times 2 minus something, right? You have to do first, outer, inner, last, combine like terms. Oh yeah, I squared is -1, blah, blah, blah. Get an answer. No. 3 times 5, 20 times 100. How easy is that? Yeah. Real numbers meaning? And yeah. You can convert this to polar form and multiply. Yeah, we're going to do that. All right, so now let me ask you this. To multiply two cis theta numbers, you multiply the r's, right? Because remember, this is r cis theta, right? The length of the vector and the direction of the vector, right? You multiply the r's, and you add the angles, right? So what do you think I'm going to do when I divide these? Divide the r's, so you write 3/5. Unless you like decimals, whatever. Cis, and what do you think the angle is going to be? I'm dividing this by this. -80. The order matters because you're subtracting, right? It's going to be 20 minus 100. Could you write this in terms of a positive angle? 3/5 cis what? -80 is down here. What if I went positive to the same location? How far would that be? How many degrees? Instead of going down 80, instead of going, what should I say, clockwise 80, I would go clockwise what? 280. You could write it this way, but that's what it means. The angles are not unique. You could write it a lot of different ways, okay? All right, so multiplying and dividing is real easy. What about powers? Or wait, just one more thing. Could you convert this back to Cartesian? Sure you can. It's 15 cosine of 120 plus 15i sine of 120. What did I do? I distributed the 15 over the cosine 120 plus I sine 120, all one swell foop, right? But you know the cosine of 120. Let's see. Here we are. 120. Where the heck is 120? 120 is over here. Second quadrant. How far from the horizontal? 60 degrees. So you know 60 degrees, right? So what's the cosine of 120 over here? It's the cosine is 60, but it's negative because the x's are negative in the second quadrant, right? Now 60, the cosine is 1/2, right? So -1/2. All right, so this is 15 times -1/2 plus 15i times, well, what's the sine of 120? Or the sine is 60, right 3/2. And that's an answer, but I guess I could clean it up a little bit. How about -15/2 plus 15 rad 3/2i? Did they do this to you in Regents last year? They said, oh, put the I before the radical? Or in between the 15 and the radical? Did they make you do that? I don't know why people do that. Well, I know why they do that. Why do they do that? You don't have to do that. I always put it on the end because I want to talk about A plus BI form, right? They make you put the I in the middle sometimes so that it's clear that the I is not in the radical, because the square root of I is a whole other can of worms. Let's not go there. If you write this really sloppy and it looks like the radical goes over the I, your answer would be wrong, right? Because I and the square root of I are completely two different crazy things. Okay. So that's why they do that. Just make sure that the I is like, not in the radical, that's all. Is this terrible? Not terrible. All right, so now, just in case you thought this was completely blowing your mind, here we go. What if Z is cis? Can you tell me what Z squared is? 4 cis 40. Because remember, what I'm saying is what I'm saying is multiply by itself, right? And we said to multiply I keep on writing this wrong. To multiply two polar form or cis theta form numbers, you multiply the number in front and you add the angles up, right? So it's going to be 4 cis what? 40. Okay. What's the original number cubed? What's the original number cubed? 6, not 6. 8 cis 60. Right. Okay, can you convert that back to rectilinear? It's 8 times cosine of 60 plus 8I times the sine of 60. All right, now 60 degrees, that's easy. You're in the first quadrant. The cosine is what? 1/2. So you got 8 times 1/2 plus 8I times rad 3 over 2. But half of 8 is 4. And again, half of 8 is 4, so what do you write? Well, I like to put the I at the end, though. So 4, rad 3, I. Just make sure the I is not in the radical. That's wrong. Okay. Now, not only is it easy to take any power you want, I could just as easily take this to the 100th power. Now you can go backwards. If 2 cis theta cubed is 4 plus 4 rad 3I, what does that mean? That means the cube root of 4 plus 4 rad 3I is 2 cis 20. You could do cube roots, square roots, 4 roots by going backwards. How do you go backwards? Let's talk about that. All right, so we're going to focus on powers, okay? This is powers right here, right? Powers is just a lot of multiplying. So you're just going to multiply the r's a lot. You're going to add the angles a lot, right? Okay, so let's do this one. What if I want 1 plus I to the 4th? How do I do that? The hard way would be 1 plus I times 1 plus I times 1 plus I times 1 plus I. So you take 1 plus I times 1 plus I, you FOIL it out, you clean it up, get an answer in A plus BA form, times another 1 plus I, blah, 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 then times another. God, you know how many mistakes you're going to make? How much paper you're going to waste? How many trees you're going to kill? Don't do that. Convert 1 plus I into a vector. So remember, you have the real axis and the imaginary axis. This is not the regular Cartesian plane. This is called the complex plane. All right? And I'm going to graph A plus BI form. 1 plus I is A plus BI, right? What's A? 1. What's B? It's also 1. Okay. So I'm going to go 1 in the real and 1 in the imaginary. Put a dot there. And how do I draw the vector? From the origin to that point. Okay? Now what I want is I want the length of that vector and I want the angle. Now if I draw a little right triangle here, it's easy. Let's blow this up. This is 1, this is 1, this is R. What's the length of the vector? Not 1. What's R, the length of the vector? Did I hear it?
1 rad 1?
Nope. Rad 2. Do you see rad 2? A squared, B squared, C squared, right? So 1 squared plus 1 squared is R squared. 1 squared is 1. 1 plus 1 is R squared. R squared is 2. So R is rad 2. And remember, we're talking about the principal root, the length. It's not positive, it's not negative. Okay, so R is rad 2. What's the angle? This little angle, I call it alpha if it's less than 90. I call it theta if it's bigger than 90. So how big is alpha? It is, but what is it? Do you know how many degrees exactly? Do you know an angle whose tangent is 1? 45. Or whose cosine is 1 over rad 2? Now, you may not recognize 1 over rad 2, but if you rationalize it, that's rad 2 over 2. Don't you know an angle whose cosine is rad 2? 45. Or whose sine is 1 over rad 2. Rad 2, right? So this angle is 45 degrees. So I'm going to say This is rad 2 cis 45. The number I'm taking to the fourth power is rad 2 cis 45. Rad 2 is the length, the r. 45 is the angle, the alpha. Is this okay? So now it's real easy. How do you take the fourth power? How do you take the fourth power of rad 2 cis 40? You take the rad 2 times rad 2 times rad 2 times rad 2. That's not bad. Rad 2 times rad 2 is 2. Rad 2 times the other rad 2 times rad 2 is 2. And the 2 times the 2 is 4. All right, so you got 4 cis. What happens to the angles? It's 45 plus 45 plus 45 plus 45 is 180. Okay. Okay. That's the answer. 1 plus I to the fourth is rad 2 cis 45 to the fourth, which is 4 cis 180. Can you convert that back to rectilinear form? Sure you can, because it's 4 times the cosine of 180 plus 4i, the sine of 180. All right, B1 with the unit circle. 180. What's the cosine here? The x value, what is it? -1, what's the sign? 0. So I got 4 times -1 plus 4i times 0 is just -4. So 1 plus I to the fourth is -4. All right, now let's go backwards. Let's go backwards. Everyone got this? We got this? Everyone okay? If 1 plus I to the fourth is -4, if you want, -4 plus 0i, right? Same thing. What's the fourth root of -4? Go backwards. The fourth root gets rid of the fourth power, right? So if the fourth power of 1 plus I is -4, the fourth radical of -4 is what? 1 plus I. But that should bug you. Because isn't that answer incomplete? When I square root 4, what do I get? Just 4. Square root 4. Square root 4. 2, or you get 2 answers, right? When I fourth root something, I should get how many answers? 4 answers. I'm really solving this equation. How do you solve an equation like this? Subtract the 4. Take the fourth root, right? So the solution to this equation, that's one of them. But since it's a fourth degree equation, you expect 4 answers. They could be 4 different real answers. They don't have to be different. They don't have to be real, but they got to be 4 of them, right? So I got one of them. How do I get the other 4 or the other 3? Yo no sé. All right. This is the problem. Right? Okay. How do you graph -4 plus 0i in the complex plane? The imaginary part is 0, but the real part is -4. So what does the vector look like? It goes 1, 2, 3, 4 this way, and it doesn't go up or down, so that's it. Right? Okay. So let's convert it to cis theta format. We're taking the fourth root of what? Well, how long is this vector? It's 4 units. 6. What's the angle it makes with the positive x-axis? 180. This is what you do. You take the fourth root of 4. We already figured out that that's rad 2. Then take this angle and chop it up into 4 equal pieces. What's 180 divided by 4? Cis 45. Now look, draw that. Rad 1.4, right? And I'm going 45 degrees, right? So let's say if that's 4 units that way, 1.4 units, 45 degrees, say is this way, right? Okay, that's one answer. That is the one we had. That's that, 1 plus I. Good look, that's where we started. That's the exact vector right here. It's the exact same vector we started with. I'm going backwards, so I end up with the same thing, okay? That's one answer. Where are the other 3? Well, how many degrees in a circle? 360. Chop that into 4 equal parts. 90. All right. So remember, this is 45, right? So rad 2 cis 45. Add 90 degrees. What do you get? 45 plus 90. 135. All right, so you have the vector of the same length at 135 degrees. That's rad 2 cis 135. All right, add 90 again. 225. Rad 2 cis 225. Add 90 again. How much? 350. So rad 2 cis 350 degrees.